So in this module, we're going to start talking about the Raspberry Pi. As compared to the Arduino, the Raspberry Pi is newer, more powerful, and so on. And by more powerful, that's a general term. I'll be more specific about that actually right now. But we're going to talk about the Raspberry Pi board. We can also use the Raspberry Pi to implement Internet of Things devices, just like the Arduino, but you can use it for different things. So the biggest key difference is that it runs an operating system, so that allows you to do a lot of different things. And we'll talk about that during the course of the module. So let's start off with the Raspberry Pi. We'll look at its hardware specifications. Now, one thing to note is that there are several different versions of the Raspberry Pi board. There was first the Raspberry Pi A, then there's the Raspberry Pi B revision 1, then there's Raspberry Pi B revision 2. We're using Raspberry Pi B+, which is not the absolute newest. The Raspberry Pi Zero is the brand new one that came out actually just a little while ago. But that's okay. We're using the Raspberry Pi B+, which actually is probably the best right now. So the Raspberry Pi B+, we'll talk about it and its hardware specifications, but the specifications of all the stuff that we're learning about the Raspberry Pi, even though the specifications are slightly tweaked for the B+, all this will apply to previous Raspberry Pi boards as well, almost all of it. Okay, so it's a Broadcom chip, the microprocessor. The chip, the integrated circuit, is a Broadcom SoC. SoC stands for System on Chip. It means that it's got a processor and it's got other things on it that make an entire system. So you take a system, you put it onto one chip. So System on Chip, that's what it stands for. But it's a BCM2836. Now, the previous boards, previous Raspberry Pis had BCM2835, which is slightly slower. So this is 900 megahertz clock frequency, 1 gigabyte RAM. That's a lot more than, say, Arduino, which was maybe 16 megahertz clock frequency. And the RAM was tiny, I don't really remember. So this is a big step up in terms of power. But that's a little bit deceiving because we're going to be running an operating system on the platform, so that takes away from its performance also. So we'll talk about that more as we go on. It's also got a GPU. GPU stands for Graphics Processing Unit. And a graphics processing unit is basically a parallel processor programmed in a different way. It helps to speed up graphics. We will not explicitly be using that GPU, although it can be used in the background by applications that you run on the Raspberry Pi, but we won't be writing code for that GPU. That's another class. 40 GPIO pins. GPIO standing for General Purpose Input-Output. So the pins that it has 40 pins. This is actually a good step up from the previous Raspberry Pi boards. They only had 26 pins on the Raspberry Pi A and B. Also, that's more than the Arduino has. Arduino has, say, let's say it has 14 digital plus the 6 analog. It has less than 40. So we got 40 GPIO pins to play with. 4 USB ports. So USB is a good thing, right? Our Arduino certainly didn't have that because Arduino couldn't support an operating system. So we've got USB ports. That means we can connect to all kinds of USB devices. Now, note that Arduino, even though it couldn't stand alone connect to a USB device, you could get a USB shield, and connect it. But that hardware is actually built into the Raspberry Pi. And this one has 4 ports. Micro SD slot. So SD cards, basically they're small flashes, right? And you might have them in your phone, something like that. So this has a micro SD slot on the back. Which is actually an important thing. We'll talk about the use of that on the Raspberry Pi later on. But the micro SD slot, it used to be a full-size SD card on the previous versions of the Raspberry Pi. Micro SD is just more compact. So here's what the board looks like. This is the top of the board. So you can see on the right-hand side, you got your USB ports. Below that, on the right, you've got the Ethernet port. So it has a built-in Ethernet jack, RJ45. So it has support for Ethernet, for wired Ethernet, built into the board. Now, there's also, if you look behind the USB ports, there's that USB Ethernet interface IC. So that's one chip that's handling the communication with the USB ports, also with the Ethernet jack. Along the top, you've got the GPIO pins, the 40 pins. Down bottom middle, you got the CSI camera connector. That's a special purpose camera connector. You can get a camera for Raspberry Pi and plug it in. Now you can plug in a camera, you can take a webcam and plug it in through USB also, but it gives you this additional camera port for its own camera if you want to use it. At the bottom, it's got an HDMI port. HDMI, so you can plug this straight into a monitor. Something else that the Arduino didn't have. Even though the Arduino, probably there's a shield available for HDMI support, this is built into the Raspberry Pi. There's a power connector on the bottom left. That power connector is a USB connector. It's not the same size USB. USB micro, I believe, is the term for it. But it's just for power. It's not for actual data communication. So when you get the Raspberry Pi, you get it with a power supply, a wall wart power supply. And you plug that one into the wall, and the other end you plug into the USB connector, the power connector USB right there. There's a DSI connector along the left. DSI is it's an interface, it's a monitor interface, so it's for displays. It's an alternative to HDMI that's sometimes used on mobile devices. It's not common though, we're not going to use that. We'll stick with the HDMI since that's the most straightforward and well-accepted interface. And then at the center left, you got the processor, Broadcom BCM 2836. It's an ARM-based processor, and I'll talk about that in a little bit. Now, let's look at the back side of the board, see what's underneath. This is what the bottom looks like, and there's not a whole heck of a lot that we're interested in here, except, well, you can see the GPIO pins, the bottom side of the GPIO pins along the top. That's just to see, just for reference, where the location is. And on the right side, you see the micro SD slot. So that's where you slip in the SD card, the micro SD card, into that slot on the bottom. Thank you.